Hello everyone, this is a system design series.
The videos are going to come up every week and it will be alternate, one video on my channel, one video on his channel, so you can check out the entire series. The link to the series will be in the description. So we'll keep creating a lot of videos on different topics, and these will be common questions as well as sort of different questions that you don't see solutions to so much.
The first one today is going to be on disappearing messages. So if you send someone a message and you want it to stay only for 24 hours, or if you want it to stay only till they have read it, this is something common in Snapchat, Instagram. That's the high-level design that we're going to be talking about today. So let's start this series. Say that we have Snapchat downloaded by a customer. So let's start there. We have a person with Snapchat on the mobile, and then they're sending their disappearing message to their friends who are across the border. And what they want to do is they want to make sure that this message is deleted after it is seen. So how should we go about doing this? Let's start with just two cell phones, and let's start with, you always need a server if you're going to send a message or if you're going to do anything.
I have a couple of questions, Gaurav. So just to set the requirements correct, okay? Yes, I know, like just setting up the functional requirements correct. I know that our main requirement is definitely disappearing messages. But then I also wanted to ask that are we going to take care of group messages or only on one-to-one messages? Because the way we handle group messages will be very different.
Let's start with the easy part, which is one-to-one messages, and we have to make them disappear. And then we can go for slightly more complex things.
How to extend it? We have to basically make it extendable. Then secondly, when we say disappearing messages, it is just disappearing after a time period, or is it like once it is seen, then it is disappearing?
So we can go for the most easy one, which is it disappears just after you see the message. And later on, we can go for more complex things like time-based disappearing messages. Yeah.
Actually, once you see, it would be more complex for group chat, and time-based would actually become easier. But okay, cool, right?
Yeah. We can go for either, but I think let's start with you see and it goes away, because I think that's the more common use case.
Correct. All right, cool. Right. Okay, so there are two major ways of handling this, right? That we handle this on the client side or on the server side. We'll obviously be trying to solve it on the server side, right? Like not everything we are leaving on the client side.
Yeah, I think some part we'll have to leave at the client, but whatever we can manage on the server, or whatever we need to manage on the server, we'll manage on the server.
All right.
So let's start with the most basic part. Then these are parts that I think most of us know. If not, then you can watch a WhatsApp system design video that I have, which is on one-to-one messaging. I think Keerti has also explained one-to-one messaging quite well. Keerti, is there any video that we can refer to? Maybe we have it in link in the description.
Yep. There are actually two videos. One I'm explaining to my father that how WhatsApp works. So that is also there. But yeah, cool. Yeah.
What you eventually want to do is, let's say Keerti is sending a message to her dad, and the message needs to be deleted in some time because her dad is at a party, and then you don't want these private family messages to be seen. Also, another use case for disappearing messages in family chat especially is because so much chat is generated every day, good morning messages and all that stuff, that you actually want to get rid of it. You don't want your system to be clogged up, your client device to be clogged up with all of these messages. So I've often seen family chats having like disappearing messages. There's nothing important over there that you can't lose. There's no need of history. So a message is going from one place to another. But this is impossible to do because Keerti's cell phone doesn't know where her dad's cell phone is. Okay, I'm taking this use case. Instead, she needs some sort of router. And in our case, because we are providing this service, we have Snapchat or we have Instagram. This is the backend chat server, which is somehow going to route this message to this mobile device. That is our basic requirement. Now, this itself means quite a few things. One of the things is there needs to be a way for Keerti's cell phone to find this server. That I think we can assume that the DNS is going to manage that. If you have a URL, Snapchat/message/ your username and so on, that URL can be hit. We are not worried about that. After that, how do you find the destination? This is a from device. This is the to devices. When you are from. So the answer to that is you need some sort of routing again. That has to be maintained by tables. So maybe you have a database which has every person's IP address. Yeah, you have the destination IP address, the mobile IP address stored over here. So you're storing.
Adding one point over here. So how does basically chat server communicate to the mobile, right? So that is one thing. So how is this networking happening? Is it a normal REST API call? I'm just making the audience also think. It can also be over a WebSocket connection, right? That because there are going to be a lot of messages, we do need a full duplex connection. It does make sense to have a WebSocket connection. So this IP address database that you're talking about, it could also be like a WebSocket connection handler that is basically storing that which mobiles, I have the WebSocket connection to which chat servers, because there will be multiple chat servers and we have WebSocket connections with them, right? So
makes total sense. It makes sense. Yeah. That's a really good point actually, because we can use HTTP here to send a message. So that would be a client to server thing. And we can also use HTTP to receive the message. Basically, the destination phone can keep pinging the server saying that, hey, do you have any new messages for me? Every 5 seconds. Similar to how email keeps pinging. So, but you don't want that in real-time communication. It's also very wasteful. Every 5 seconds you're messaging, despite there being potentially no messages on the server. So if you had a fully duplex connection like Keerti mentioned, it's awesome because you can send and receive messages. So it's two-way communication.
The one that you were talking about was basically polling, long polling or short polling. But then why do that, right? So WebSocket connection makes sense.
Makes sense. Also, you have this now database which is not storing IP addresses, but it's storing a connection. It's a connection handler. It can tell you where a person is connected. Okay.
Correct.
Internally, it's probably going to be storing some connection information, whether it is IP address or it's some connection information has to be stored so that you can route it. Yeah. That's interesting. You mentioned port because in this chat server, maybe you're receiving messages on one port and maybe you're emitting messages from another port. So the same application can be using different ports. So, okay, Keerti, I see that you have drawn a load balancer. So we are already having at least 10,000 customers, I guess. Yeah, Snapchat, WhatsApp.
Yes.
They have more than 10,000. Okay. So could you explain to us what this load balancer does?
So basically, there are going to be different chat servers, right? So obviously, there's going to be a reverse proxy. How do you know that with DNS is there? I know, but there's not just one chat server, right? There are multiple chat servers, and this is not the only request that we're going to get. There are going to be multiple requests. So you could also see it as an API gateway. Basically, I just added a reverse proxy, which can be a combination of load balancer and API gateway.
Okay. So this load balancer is going to be taking our messages, and it's also, is it going to have WebSockets connected to it?
So I don't think we should be connecting to load balancer, but since I said it can be a combination of API gateway, but I think connecting it directly from chat server does make sense, right?
Yeah, and so if we have a very small system, one chat server can manage. I think having a load balancer makes a lot of sense. If you have a DNS here, which has addresses to all these chat servers, that is possible, but then DNS-based load balancing, better than that, you having control by having your own custom load balancer makes total sense. Okay, so we have this load balancer which connects to different chat servers. I think having WebSocket connections here is good. We can have a load balancer which has, and we then have a chat server, 3 chat servers, very nicely aligned. Okay, there is a bit of a problem now. What if the source mobile maps to this chat server, this request goes here, and is it possible that you're sending chats to, what is the purpose of having multiple chat servers? We should have multiple load balancers, I guess.
We should have multiple load balancers because every machine can have obviously limited number of WebSocket connections, right? Limited number of ports, a limited number of WebSocket connection. So how I saw like load balancer, basically instead of having the WebSocket connection with the load balancer, you could also have with an API gateway which is attached to the chat server. So instead of exposing the private IP of the chat server, you're basically exposing of the API gateway. Now load balancer is just to distribute the load, but the WebSocket connection is actually with the API gateway, which is like basically with the chat server. So that is how I was thinking. But it's okay. We can have WebSocket connection with the load balancer as well. But then that also limits us to that uh, there are going to be limited number of connections, right? So multiple chat servers for those, say, what, 50,000, 60,000 connections? I'm not sure if it makes sense.
The problem is if we have HTTP here and let's say a WebSocket here.
Why a WebSocket over here? Like HTTP converted to WebSocket, right? So you can have basically directly with the chat server, like this basically this. Why not directly with the chat server? It is just that the first time the request comes, it is going to direct to this chat server, and then the WebSocket connection is going to be with the chat server itself. Does that make sense?
So why is the load? What is the load balancer doing?
So the first time the request is going, probably it can go to the load balancer, and then it can balance and see ki where should this should create the WebSocket connection with chat server, and then after that there is a full duplex connection with the chat server itself. Then load balancer doesn't have to be involved.
So we are basically assigning a chat server. The first time we send a message, the load balancer returns a chat server that they need to make a WebSocket connection.
Yep.
Okay. So let's say this is the. Okay. Is there any other way we can do this? Should we consider? I mean, I see that the load balancer is basically it's good. It's a load balancer. It is balancing load. It is telling you which chat server to connect to. Okay. Right. And then you build a WebSocket connection with that particular chat server.
Do you have any other approach in mind?
Yeah. Actually, no. This is good. We have a load balancer, and the load balancer is literally just balancing load, which is good. Okay.
Also, this WebSocket connection handler. So basically, it is sort of like a address database, like sort of a map, as you had initially said. So it does make sense to probably use a key value store like Redis, which also gives us persistence, but is also fast.
Okay. So you want to cache these IP addresses.
Yep.
Makes sense. Okay. So now here's the interesting part. How does a person send a message from his mobile to this person? Like how does the chat server know where to send it to?
Correct. So let's say one flow, like suppose from this mobile, we have a WebSocket connection to this chat server, right? Suppose this chat server is 2. And now suppose we have no idea that where is this 2 mobile connected to, right? So for that, we basically go to this connection handler and then we say key, okay, where is this 2 mobile connected to? And then it tells that, okay, it is connected to this chat server. Now again, there are 2 approaches that either this chat server can directly send after like knowing it is connected to chat server 3, or we could probably send from here, or we could add something like Kafka in between, just telling you different approaches. The main point is that this connection handler is going to tell us key where is to mobile connected to. Does that make sense?
Yeah. That makes total sense. You have a person who is connected to chat server 2. So let's change the color of this so that it's easy to understand. Let's say red, and you have from as red, and then you have this person in blue, and this is also blue. Now it's clear that it has to go from red to blue. So when does it go? It goes from mobile to chat server 2, where it's connected. It got this connection because it went to the load balancer, who knew that you belong here. Someone else belongs somewhere else. Okay. So the chat server 2 now needs to send the message to the destination. The way it does this is there are two ways to do it. One is to go to this IP address table, and the other one is to actually just go back to the load balancer. I'm sorry, I won't delete that, but yeah. The other one is to just go to the load balancer and check where is destination connected. And whatever response it gets, it can use that to find where to send the message to.
If we can do that from the load balancer itself, then though this connection handler is not needed, right?
Yeah, I guess this connection handler, whatever we like to call it, is
basically
the load
doing
balancer
what.
also. Yeah. So whenever a person wants to know where a mobile should connect to, mobile A should connect to mobile B, this has some sort of a mapping of A belongs to chat server 2, B belongs to chat server 3. And in that way, all the chat servers can just use this connection handler, and even the client devices can connect to the connection handler to know where to connect to if they are not sure
Right.
where to do.
Yep.
Okay.
I would like to add a couple of points over here.
Sure.
One thing, that suppose A and B were connected to the same chat server, then there is no point of asking the connection handler again and again. So first thing that the chat server 2 could cache is that who are connected to itself, right? So if suppose the destination or the two mobile is connected to the same chat server, we do not need to keep asking to the connection handler. That is one thing that we could cache. Another thing that we could cache is basically the frequently accessed, like messaged people. Like for example, I message my father a lot, then we could probably cache that, but then with a very less TTL, so that even if B mobile is suppose connected to some other chat server, then the TTL should be very less, right? So that we can basically update it from connection handler. Just a few seconds, but probably we can make it more efficient like that.
One of the things that we can do is that, like you said, there's an approach of caching, which is perfect, right? We can go for the caching approach. Another approach is to actually have some sort of a small, like a mini, cache inside. We can call this a client. This is some piece of code. So I'll just color the connection handler differently, yellow, right? And I'll make this also yellow.
Okay, got your point.
So now what happens is, like you said, the cache, it's perfect. We cache things on the client. Whenever a person says, listen, where is mobile B? The chat server has no idea. Chat server just says, client, find out where is mobile B. And if the client has it cached, it sends the message to chat server 3, which sends it to mobile B. Otherwise, it calls the connection handler. So actually, this thing is always happening from the client. The caching, how long does it keep the cache? What kind of algorithm should you use? Like you said, recently used people. So for example, if a chat starts, it doesn't end very quickly. This recently used is a good algorithm here because Keerti is chatting with her dad. She's going to chat for 10 minutes. And once she stops chatting, she's not going to chat. She's not going to chat for a while. So it's good to remove her from the server quickly. So you can use different algorithms here, but yeah, this is great. If a person wants to send a message from one place to another, we have a mechanism to take care of that. We are able to scale this also quite a bit. We are able to add servers. A single connection handler is there if you want to. This is backed by some database somewhere, which is going to keep a mapping of which user is connected where, right? Okay.
I have a question, Gaurav. So are we storing the messages or are we encrypting it and not storing it anywhere? Like, are we directly sending it to the two mobile and not storing it anywhere, or are we storing the messages? So
if it was Slack or some sort of team communication, then it would be very important to have it audited, because someone says something and later on says that I never told you to. That would be very scary. But in case of this, the whole the use case of the applications somehow is it doesn't get stored anywhere.
Correct.
Yeah.
So we are just encrypting and sending it, right? Now my another question is, my another question is that what if the user is offline? Like for example, B is offline right now and we send a message. Then what happens? Do we put it into Kafka or like what do we do?
Yes. We will put it in some memory data structure, whether it is, but we will not give any guarantee that the message will reach. So for example, Keerti, you send a message to your dad and your dad is on vacation and he's going to come back after 6 months. So despite the server getting the message, it's possible that he never gets the message.
Right.
That is always possible. Yeah. That's a good point actually, because it brings us into flow, the flow of how the message reaches. We know how messages reach. Now, if we want to see that the person has actually read the message, how do we get that? First thing would be you send a message to the chat server. When the chat server gives an acknowledgement, we know that a single tick comes on WhatsApp. Server's got the message, most likely your friend is now going to be able to see it.
Yep.
The second that chat server 3 forwards the message to mobile B, that's when, and B gives the acknowledgement, okay, I got the message. That's when the acknowledgement reaches chat server 3. Chat server 3 says, okay, where did I get the message from? Who's the source? Where is the source? It finds that chat server 2 is the source. Okay. Again, it goes to a connection handler. It can't do this by itself. If the client caches it, it's okay, but otherwise it goes to a connection handler, gets that A is connected to chat server 2. Chat server 2 sends a message to mobile A and says, the destination device got the message.
Correct.
And finally when B opens the app,
the duplex connection really helps over here, right? Because we are able to quickly communicate. Yeah.
I see that B migrated very quickly. Now when B actually reads the message, one of the things we can do is we can have B reading the message here. Again, it goes to chat server 3 saying that I've read the message. It finds where A is connected, chat server 2. It then sends a read receipt, and on your mobile, you'll be able to see a blue tick. The 2 ticks will become blue. So that's great. A few things have to happen with disappearing messages, but let's just start with the point that you had, Keerti, that what if a person is offline? How long do you store these messages? So one thing we can do is we can give them a time to live. These messages can be there at most 7 days, because they seem like you want them to disappear. So in 7 days, if the person has not read it, it's not going to stay on the server. Despite it being encrypted, we will delete it. That's one possibility.
Right.
I think, or if we have an overflow of system or something like that, we'll delete the message. That's also possible.
So where do we store the message for 7 days? Or for whatever
So
time?
We can store it in the chat server itself in memory. It will go like in a queue data structure in the chat server for this user. So they go one by one.
What if the chat server goes down?
Yeah, we lose the message. That's okay.
Oh, so we are okay with that?
Yeah.
Suppose we were not okay with it, like we should not lose the message for 7 days then?
So we would need some sort of a database which would store that message, and then we could retry it. Some sequence number would also need to be there, making sure that those messages are received in order on these mobile. Maybe a timestamp, local timestamp will work.
I think we can get to the disappearing messages part now.
Yeah, so interesting part. When B has read the message, normally in WhatsApp you get that double tick. Here, if B has read the message and you're looking to delete the message from device, so where does that start? So one of the things is it has to be deleted on both devices, not only B but A also.
Correct.
So let's say B starts with the deletion. So they watch an image or they read a message. As long as the mobile is open, as long as that tab is open, I don't think the message will get deleted. The moment they close that tab, there has to be some client code which is going to delete the message from their device. So we have to rely on client here. Yeah, so once the message is deleted, in parallel, it can send an acknowledgement that I have read the message, right? So the moment you get an acknowledgement, whenever that double blue line was going to be there, chat server 3 gets this read receipt, deletes the message from its local memory, sends acknowledgement to chat server 2 saying, please delete it from your local memory also. Chat server 2 also deletes it, and now goes and tells mobile A, listen, the message reached, it has been read, I'm now going to delete it. So mobile A then goes and deletes this message when you move out of that tab. So it might have a set of messages that it's supposed to delete when you switch tabs. This would be a flow of the message deletion. I think, this is how
there are a few repercussions. What if A is offline? Like when this guy reads the message.
So if A is offline and we keep trying to delete the message, we'll keep trying for a while, but again, we have no guarantees that.
So there should also be some mechanism that after sending, like suppose even if it doesn't get delivered, after sending also after a while, say 7 days, we are like discarding the message, right? Then in that case, we should delete from A as well. Suppose we did not get the delete message or B did not get the message, in any case, we should be deleting it from A as well. So that will also be taken care of on the client side probably, that okay, it has been 7 days, this was sent and this has not been deleted. So it's time that we delete the message.
Possibly, yeah, possibly. Or maybe you keep it forever is also possible. Let's take an example. We send a disappearing message to a party, to a destination. The destination doesn't see the message for weeks, in fact years. They're not interested in that message. So now mobile A can keep it hanging around for that message forever, which might be okay.
These are the kind of decisions we would have to make, because we are not letting B never read the message, right? We are deleting it after a week.
Yeah. In fact, we are deleting it from our server, but we might know that B has gotten the message. It reached their mobile. We got the acknowledgement, but they're not reading. They're never reading this message. So although the mobile has given the acknowledgement, and this is, I guess, a pretty common scenario, right?
Yeah. We don't open the message and it is there. Yeah.
Yeah, it's just there forever. So read receipt is never going to happen. In which case, chat server 2 never tells A to delete the message. That's fine.
So in a sense, the read receipt is now replaced by the action that delete the message. Yeah. In very simple terms.
That actually sums up the whole design.
Yeah. Yeah. I think it will be far more complex in a group message, or especially like when we have to consider the delete after some time. So should we start talking about that as well?
Yeah. I think group message, do you want to give it a shot, Keerti? What do you think will happen if there are multiple people here? I'll just draw them up. Let's say
so the complexity over here is that, do we delete for only that person when like the message comes, or do we delete from the group together when all the people have read it? So how does it work? Because it would be very weird. Some people can see it, some people cannot see it, right? So even if one person doesn't read the message at all, then it is always there. That means everyone has not read it.
Not everyone has read it, that's correct.
Yeah. So the moment everyone reads it, we are going to delete it, right?
Yeah.
So now the thing is that now we cannot handle it on the client side, that the person has read it, so we are going to delete it. Now this has to be done on the server side, that out of these, suppose 100 people in the group, I know 100 is a big group, but suppose 100 people in the group, how many have read it and how many have not? Like, is there anyone who has not read it? So it is sort of like a visited set. How many of them have visited this particular message? And the moment everyone has visited, we are supposed to delete the message. Now this has to be kept on server for every single message, which is actually a lot of data to keep. So should we, like, if we do that, should we talk about how would we store this data? For every single message in a group, that we could also keep a counter that how many people have actually. But then again, it becomes complex in the sense that if someone leaves the group, suppose I send the message, there were 10 people. So we were waiting that the count should become 10. But now someone leaves the group. So now actually the count should have been 10 or 9. We do not know. It should have been 10.
Yeah,
but
someone
now
leaves
we
and
might
someone
have
gets added.
Yes, in both
that's
the cases.
Also possible. That.
Yeah.
So the person who read it has left while a new person came in and they haven't seen it. So I think what we can do then, let's start with the basics. How would we send a group message? Let's not go for disappearing right now. How would we send a group message in this? So we have multiple servers, multiple people connected to each server. If A is sending a group message, what are some of the optimizations we could make? Because if 100 people are there, it's going to broadcast to 100 people. So how would we?
I don't think it should be the chat server 2 who should be messaging to the chat server 1 and 3 like directly. That's why initially I was saying that probably having something like Kafka or a middleware does make sense, because even if they are offline, you're basically putting it to the Kafka and they can pick up the topic as and when, like suppose B comes online or D comes online. And that would be very helpful for group messages as well.
Let's say you send a group message of hi and it reaches chat server 2. That's where you are connected. Now, B, C, and D want to get this message. The brute force way, I guess, would be find out where B, C, and D live through the client device one by one. is there an optimization we can make here? Like 1 by 1 would be 3. So order n algorithms. A lot of algorithms I'm using here, but how can we speed this up? Is there an optimization here?
Or probably just, as I was saying, like probably have another server who's responsible for the group messages to send the group messages.
Okay. So we send a message with a group ID saying that, I'm part of this group. I'm sending a message to this group.
Also, it is not like chat server 2 knows that who all are there in the group. There would be basically a group DB which would have all the information, right? That who all are connected, who all are part of this group, basically, right?
Makes sense, yeah.
So it does make sense to have like a separate DB that is going to take care of it, like separate server who's going to take care of it for us.
Okay, let's assume that we have this thing working for us, and the group service has a clear mapping of who is connected to which group. Gaurav is connected to Mumbai group, is connected to system designers group, and so on. All the WhatsApp groups that he's part of.
Would you like to quickly discuss that? How are we storing the group database? That in this group, who all are there? So the usual query that is going to come is that in this group, who all are there, right? Not that this person is in which all groups. Like the more common query is basically in this group, who all are there.
Yeah.
So how do you want to store it? Which DB?
When I open my cell phone, I want to know which all groups I am a part of. That is one type of query. The other type of query, like you mentioned, is who are part of this group. So both are reasonably common. What I would store is a table of relations. Gaurav is part of this group, and so if Keerti is also part of the same group, then it will be Keerti is part of group ID 1. Gaurav is part of group ID 1. And Gaurav is part of some other group also, so group ID 2. So you have two-way N is to M relation, where Gaurav is part of many groups and a group has many members.
I would personally not agree with a SQL DB over here. Firstly, because vertical scaling is going to be hard and then you have to keep checking the relations, versus something like a MongoDB which has that in this group, these are the user IDs, would make more sense for me because the querying would become a lot more efficient. Also, to the point that you can comment on it. Obviously, there's no right and wrong. I'm just giving the reasoning because there are going to be so many users, right? And any user could be connected to anything because horizontal scaling is hard when it comes to SQL DB. And also to the point that I am connected to which all groups, we could obviously on the client side also there can be like a small DB like SQLite, right? Which has information that I am part of which all groups. What do you think?
I think, I would probably cache this stuff. Again, like you had the idea of, client having least recently used stuff. The group service can also have, when a group is talking, they're talking. And when they're not talking, nobody's there. So maybe I can cache that information locally and then respond to queries. So if a person is added to a group,
if you're saying SQL DB, I have some questions that how would you handle this? Because suppose we have like a huge database, right? Like suppose there are 1 billion users. WhatsApp has 2 billion users, right? Let's say 1 billion users. And obviously they're going to be across different DB servers. Now, in one group, there are some that are connected to one DB server, one connected to another DB server, another connected to another DB server. Then you would have to essentially get info from different DB servers. And where would you you would be caching on one DB server, right? Then you would have to join it together in the group servers. Is that what you are talking?
No, I'm not talking. I actually didn't mention SQL, but if we are doing it in SQL, sure. That is one way. NoSQL also will have to do the same thing. You will have to eventually scale horizontally if you have billions of groups. So let's say there are billions of groups. Different people are part of different groups. Let's forget caching for now. We are not going for a graph database because in groups, I don't think we can do it, but I'm not going for a graph database. Let's go for a simple SQL database. In that case, we would have to have multiple servers managing group data. So I'll just draw that out.
By the way, I'm sorry. I thought you said relational data, like relations. That's why I thought that you're assuming SQL DB.
Okay. No, the way I was storing it is as relations. Maybe SQL DB will be really good for that kind of query. So let's say we have 3 of these and we store data randomly here. We don't store it partitioned according to user or anything. We store it partitioned according to group ID, which can be any. So
Okay.
now if we have this and I want to find all the members of a group, it becomes easy. I have to just hit one partition.
Interesting.
Yeah, but if I want all the groups that Gaurav is a part of, then I have to hit all partitions.
Okay.
That would be, if I'm assuming that the first type of query is more common, that who are the members of this group, then I will partition according to group ID. If I see that this person is part of which groups, then I'll partition according to user ID. I guess you and I are both assuming that we are assuming that it is going to be partitioned by group ID because usually you want to find all the members of a particular group.
Gaurav, I have two more possible solutions and then you tell me which one do you prefer. One more is that what if Cassandra, which is a columnar DB, and why am I saying that is because there the data is stored column wise, right? So suppose my table looks like something like this. So this user connected to this group. So our actual query is along a column, which will be very efficient for columnar DB like Cassandra. That could be one reasoning that I could be okay with. Another thing, because it is going to be a read heavy operation as well, and we might need flexible schema because we do not know that in a group tomorrow what all things we need to store. Like today, maybe there is something, and tomorrow we need to store something extra. That is one reason. Also, if I store in MongoDB, it could also be like that group ID, and then there's basically an array of user IDs that are connected to that. That is very simple. I basically don't have to do any joins and get it from different basically, servers and put it all together. So obviously there's no right or wrong. But out of these possible solutions that we have discussed so far, what makes most sense to you?
See, if you are going to scale horizontally, if you need to scale horizontally, right? Billions of flows can be stored in a single node without any problem. It's not at all hard. But if you need to scale horizontally, let's say if this is a necessity, then whether it's NoSQL or SQL, this has to happen at some point in time. You will have to move some groups into one node, some groups into another. Yeah. So in that case, whether you use MongoDB or whether you use Cassandra or anything, you will need to scale this way.
But considering the query, which DB would you go ahead with?
Because there are aggregations involved here, I would probably go for a DB which gives this off the shelf. So a NoSQL database like Cassandra, if I'm running all this on AWS, then I would just use DynamoDB.
Okay.
Yeah.
Cool. I think we have discussed enough pros and cons, I think. Yeah.
We have this group service now, but I think it's pretty important also that we discussed it because without it, it's not clear. So we have for a particular person A sending to group G, they're all part of the same group G. This client goes and firstly, the chat server is going to say get members. The group service is going to respond to it by finding out that, okay, group G belongs to this DB. Let me get all the group members, give that as a response. Now, chat server 2 has only one option, which is to talk to its client and say, get me all the chat servers which these group members belong to. That is the only thing that can happen. Let's add another user. So user E is here. They are light green. So is this.
So you're saying after getting the members, it is this chat server 2 itself that is sending to all the group members?
Yeah. So it's going to go and talk to the connection handler saying that tell me where
each of those group members are connected.
Yeah. So how would you optimize this, Keerti? Any idea on, I need 4 members. So that would be 4 API calls. Any improvement that we can make here?
Do you want chat server 2 to do so much? Can we delegate it to another server?
We could, but somebody has to send the messages. Somebody has to find out where these connections are. So maybe we can use our API currently just takes one user and gives back one response. Is there a better way?
Yeah, obviously, like we can have for multiple also, like we could have another API for multiple, and in the payload we could send like array of basically user IDs that, give us the where these are connected, and in the response also in the payload we will get for like this is connected to this is connected to this. So that would obviously be more efficient. Instead of 4 calls, we're making 1 call.
Right. So makes total sense. B is connected to 3, C is connected to 2, D is connected to 3 again, and E is connected to 1. So this would be a single response instead of giving one by one. So we have a connection handler that gives us all of this stuff. Now, it's a group message. So we send the group message to chat server 1 and chat server 3. and we give them they themselves expose an API where we tell them that, look, 3, you send it to B and D. I am going to send it to C. This is chat server 2. And 1, please send it to E. And so all these chat servers, they broadcast the message in the end.
Yep.
So that's a group. Yep. Okay. Now all we have to do, we are able to send group messages, we are able to send disappearing single messages. All we have to do is make that group message disappear. So, and the problem is that different people are connected to different chat servers. So they have their, we need a way to tell that everybody across the different chat servers have actually read the message. Yeah, that is a bit challenging actually.
I think we would need another DP for that.
Yeah. Yeah, we can't have it like it would be mad for all the chat servers to coordinate between each other and say, listen, I got something. I think we need to centralize it, and we can see that the centralization is here.
Yeah, like per message, the info has to be that it has been, read by how many of them.
Yeah.
How would you store that, Gaurav, now?
Just to simplify things, I would probably say that, this message ID has been read by which parties. That is the mapping we need. So the moment all group members are covered in that message ID, then we delete from all the group members. So let's take a simple example. Gaurav sends a hi. The hi reaches everybody. When D opens their mobile and they see it, so chat server 3 gets an acknowledgement, or not an acknowledgement, they get a read receipt. So Gaurav sent a hi, D has read it, chat server 3 got the read receipt. They need to store this somewhere. They need to say that D has read this message of Gaurav.
Gaurav, I have an interesting sort of out of context question. Okay, so when our initial flow, right, that when one message goes to another message, where is message ID generated? Who is doing that? Because in this, we would have to store that this message ID, because we are not storing the message, right? So this message ID has been basically read by these many people in the group. But now the thing is that our different chat servers are taking care of it. So who is generating this message ID now?
Yeah. So I think the message ID can either be generated by the client. They can send a UUID. They can also send, because you want these ordered according to timestamp, ideally the client can just generate the message ID as for this group, this user, like you append that information and say at this timestamp, I sent the message. So that's also a unique ID. Yeah.
Who is sending it to? Basically, 2 can be either 1-to-1 or it can be a group. So who is sending 2 and basically the timestamp, right? So 3 things will together make the ID. Just making it clear, because these sort of questions just do come, right? Like people do not understand it, who is generating it. Okay. And then this message ID or this UUID is going to be our basically reference that, okay, it has been read by these many user IDs, right? Okay.
The reason client is generating it is because if the client wants to retry sending the message, at least it can use the same ID. So for example, your internet connection is spotty, you went through a tunnel, you sent it once, you come out, you didn't get the acknowledgement, you send it again. So it won't be the retry will be idempotent. It will be executed only once.
And actually every time a user reads the message, like for example, B read the message in the group, right? So in that time, we can check in the DP that, okay, now we are marking this as read. Does that mean that everyone has read? Okay, at any point when we see that everyone has read, at that time, we can send the message to everyone that, yeah, you need to delete it.
Yeah. The same logic that we had for like one-to-one messaging, we are just trying to replicate it using this central store of group service. So this message was read and now everybody needs to delete it. So the problem here is that these messages will tend to hang around for a long time. So that will be like a lot of hanging around messages. And also for every message ID, there's potentially 100 or 200 people who you have to tag, like this person saw it, this person saw it. So
and we have to keep checking also, did everyone read it or not? And instead of like, okay, just making it a bit more obvious, it is very low level details, but instead of saying that this message ID 1 has user 1 read it, has user 2 read it, has user 3 read it, keep like only those users who have not read it and keep removing users as they read them. And then in the end, if there is no one left, then you're supposed to like check from the group service that who all are part of that group and then send message to that. And every time we could also handle people leaving and entering a group like this, that someone leaves, you remove from that basically set of user IDs, and someone enters, you add to that set, all the sets of messages that are there for that group.
Yeah,
What do you
whichever
think?
one's active. Yeah.
Yeah,
I think that's a great idea. Whichever messages are active in memory,
Yeah.
if you have not seen it, we will wait for you to see it. I don't know if this is the best data structure, but this will work. If you have a map of this ID has been read by which users or has not been read by which users, it will work because as you get the read receipts, you will keep removing them from that message set. Only problem is for every message you are going to be storing the entire set of users' IDs. So let's get a capacity estimation question here. I think we have how many messages will be sent per day in a group. And we have to just message ID versus user IDs. So let's say 200 people. So 200 user IDs will be, let's say each user ID is 64 bits long. So that is
how many
8
bits
bytes.
long did you say? 8 bytes.
64. Okay. Yeah.
Okay.
So 8 bytes. And then we have, let's say in a day, these guys are generating 1,000 messages. It's a, I don't know if you have seen this, the way that taxis, they are part of hundreds of groups with thousands of users in cases because they are looking for like business. So people keep posting, hey, I'm in Pondicherry. I'm 200 kilometers away. Well, so it's possible. Such groups are also possible. Really hot groups. And they send a lot of attachments also. So the CDN is also getting a lot of load from these guys. So
each message will be how many bytes? Roughly, I think.
I don't think we need to store the message. We just need to store the ID of the message. So each ID will be, let's say, 16 bytes. Let's say 120 bits or 32 bytes, 256.
Okay.
Now we have 32 KB plus. That's nothing.
That's nothing exactly.
Yeah, but this is one group. So
32 KB plus 200 into 8, so 1600. So okay, I can even ignore that. Yeah. So 32 KB for one group. Like this, what?
One day.
Max, like we can say 1 billion groups, right? Makes sense?
Yeah, that would be in terabytes. Yeah, that would be too much, but 1 million is more reasonable.
Okay, all right. 1 million groups, right? So into.
I think there are 32 GB here. 32 GB, yeah, you get these computers. A single one should be able to handle all read receipts.
Yep.
Even if it can't, right? We can horizontally scale this. It's not a problem. This is sharded by group ID. So.
Yep.
Yeah.
Makes sense. Doable. Cool. Okay. Would you like to quickly recap? Because I think we are almost done with 1 hour.
Yeah. So what we did is initially we looked at how to send a message from one place to another. Critical component of this is the connection handler, which helps route messages from one place. Basically stores the information of who is connected where. So in that way, we can route a message from any chat server to another and the final destination. We spoke about how acknowledgements, whether it is delivery or read receipts, are made. And in our case, because disappearing messages, read receipt is equivalent to deletion on client devices. Hard part was group messaging. We talked about how the group message or the groups can be stored in databases, who is part of which groups. We're sharding by group ID because that's the more common type of query. A group contains which members. And once we get all read receipts from all members for a message from their clients, we then go update the group service. All the messages, all the read receipts will basically remove all users from this message ID key value pair, and then we can send a broadcast delete message to all group members. So that part I think wasn't very clear. We can send a broadcast delete message to all chat servers saying that please delete this message ID. Or at least we can send a delete, we can broadcast to the set of nodes, these chat servers which are belonging to that group. That can also be. That is known by the group service. Yeah. And how does the broadcast happen if someone has like final query? You can go to the connection handler. Again, you can go here and have a client here also. So when you are asking for deletions, the client manages that.
Great, this looks good, I think. Yeah.
Yes. Nice and colorful. Oh, awesome.
We hope you all had fun, and please do let us know in the comments any feedback you have, anything else you would like us to cover. We would love to have you all also on board for the more discussions. And if you have any questions, we would love to see your approach as well. If you have any pointers about how we could have improved this design, let us know. We would love to discuss in the comments.
Okay, and see you guys. Take care. Bye-bye.
See you next time. Bye.